course, we learned about geological processes. This includes volcanoes, tsunamis, and earthquakes. An earthquake is a movement or trembling of the ground that is caused by a sudden release of energy when rocks along a fault move. Earthquakes are the result of the elastic rebound. Well, what is the elastic rebound theory? It explains how energy is stored in rocks. Rocks bend until the strength of the rock is exceeded. Rupture then occurs, and the rocks quickly rebound to an undeformed shape. Energy is then released in waves that radiate outward from the fault. You may be wondering, what's the anatomy of an earthquake? We know that an earthquake is the shaking of the ground caused by sudden motions along faults or fractures in the Earth's crust. Let's look at this diagram. A fault is a fracture in rocks that make up the Earth's crust. The epicenter is the point at the surface of the Earth directly above the focus. The focus is the point within the Earth where an earthquake rupture starts. Plates are massive rocks that make up the outer layer of the Earth's surface and whose movement along faults triggers the earthquakes. Seismic waves are waves that transmit the energy released by an earthquake. Let's talk a little more about seismic waves. As rocks along a fault slip into new positions, energy is released in the form of vibrations called seismic waves. These waves travel outward from the focus in all directions. Seismic waves can be classified into two main categories: body waves and surface waves. Body waves are a seismic wave that travels through the body of a medium. They consist of P and S waves. S waves are secondary waves. These cause particles to move in a side-to-side direction perpendicular to the direction in which the wave is traveling. P waves, aka primary waves, are the fastest waves of an earthquake and are often the first to be detected. These waves move parallel to the direction in which the wave is traveling. Surface waves, on the other hand, are a seismic wave that travels along the surface of a medium. These have a stronger effect near the surface than it has in the interior. Surface waves form from motion along a shallow fault or from the conversion of energy when P and S waves reach the Earth's surface. Although the surface waves are the slower moving waves, they still cause a great amount of damage, more than body waves do. So we are aware that earthquakes can cause a lot of damage. It is important for scientists to study them so we can prepare. Seismology is the study of earthquakes and seismic waves that move through and around the Earth. A seismologist is a scientist who studies these things. A seismometer is a tool that responds to ground noises and shaking such as caused by earthquakes, volcanic eruptions, and explosions. They are usually combined with a timing device and a recording device to form a seismograph, as shown in the diagram. This is an ancient Chinese seismograph. It shows how people in ancient China were able to find out where earthquakes were coming from. First, grab a pencil with an eraser. Cut the eraser off and make sure it's completely flat. Then grab the Play-Doh and make it into a ball. Stick the pencil in it to make it stand. Next, put little bottle caps all around. Take a marble and balance it on top of the pencil. In the case of an earthquake, the marble will fall in the direction of where it came from. And that's the experiment. Wasn't that cool? Hope to see you in Earth and Space Science next year.